In this video, we are going to see all about Terraform versioning. Before watching this video, I highly recommend you to watch my previous video on introduction of Terraform. I'll provide the link in the description. Terraform is an open source tool for infrastructure as code. It lets you define and manage your cloud resources like server, network, and database using simple configuration files so that your infrastructure is automated, consistent, and repeatable. First, let's see what happens if you don't set up version in Terraform. If you don't set up versioning, Terraform will download the latest available provider version. This might sound fine, but here is the real problem. Different team members could end up with different versions installed. Your CI/CD pipelines might also use different versions than the one you tested locally. And when that happens, breaking changes can suddenly show up in production without warning. Debugging becomes very hard when everyone is in different versions. Plus, you will start seeing infrastructure drift between environments since every environment could run slightly different provider code. That's why versioning is very important in Terraform. It keeps your infrastructure consistent, predictable, and scalable across all environments. So what exactly is Terraform versioning? Terraform uses something called semantic versioning to manage compatibility and changes. The version format follows the structure of major, minor, and patch. For example, 4.14.0. Versioning applies three key components: Terraform core, providers, and modules. It is critical because it helps maintain stable and predictable infrastructure as code. By locking version, you can avoid unexpected breaking changes in production environments, and everything stays consistent across teams and pipelines. Let's understand semantic versioning in detail. First, let's start with major version, which follows the format x.0.0. The major version is incremented when you make breaking changes to your software. Breaking changes are modifications that may require user to update their code when they upgrade. For example, Azure Resource Manager moved from version 3.0 to 4.0. They completely changed their authentication methods. This wasn't a small tweak. The existing code would break without modifications. Next, we have minor versions shown as 0.x.o but in backward compatible manner. That means user can safely upgrade within the same major version without worrying about their existing code breaking. When Azure CLI went from 4.13 to 4.14, they added support for new Azure resources. The existing feature still worked exactly as before. User just got access to additional capabilities. Finally, the patch version uses the format 0.0.x. These are bug fixes and minor improvements that doesn't change functionality. They are always safe to upgrade because they only fix issues without adding features or breaking existing behavior. For instance, version 4.14.0 to 4.14.1, this might fix specific bugs that causes problem, but all features work exactly the same. So remember, major means breaking changes, minor for new features, and patch for bug fixes. Understanding this system helps you make information decisions about when and how to upgrade your dependencies. Now that you understand semantic versions, let's talk about version constraints. How you specify which version of a dependency your project can use. First, the equal sign. When you write equal to 4.14.0, you are pinning an exact version, that is 4.14.0. Nothing else will work. This will give maximum control, but means you won't get any bug fixes automatically. Next is exclusion, that is not equal to operator. If you specify not equal to 14.13.1, it allows any version except 4.13.1. You might use this if a specific version has a critical bug you need to avoid. The next is the greater than sign. That means any version after 4.0.1 or higher. Note that 4.0 itself is not included. The next is greater than or equal to. It includes 4.0.0 and all higher versions. This is useful when you need features introduced in version 4.0 or later. The next is the less than operator. If you specify less than 5.0, it gives you anything but not including 5.0. So you would get up to 4.99.99. This is great for staying within a major version to avoid breaking changes. The next is less than or equal to. If you specify less than or equal to 4.14, it means up to and include any 4.14.x patch version. The next is the tilde operator. If you specify tilde operator greater than 4.14, it means to stay in 4.14 series. So you get 4.14.0 through 4.99.99. This allows minor and patch updates but prevents major versioning changes. The next is combining constraints. You can also combine constraints. For example, greater than equal to 4.0, comma, less than 5.0. This means any version from 4.0.0 up to but not including 5.0. This keeps you in version 4 family. Another example is greater than or equal to 4.13, comma, less than or equal to 4.16. It lets you lock between 4.13.0 and 4.16.x. This is perfect when you need features from 4.13 but you know that 4.17 might have a breaking changes. The next is a complex one. If you specify greater than or equal to 4.10, comma not equal to 4.13.1, comma less than 5.0, this means give me anything from 4.10.0 to 4.99.99, but skip the version 4.13.1 because it has known issues. Understanding these constraints helps you balance stability with getting important updates. Choose the right constraints for your needs. Now let's see the practical implementation of Terraform versioning. Let's see the demo. Here is my Visual Studio code. And if you see here, I have main.tf file. First, let's see the structure of this file. We have a Terraform block. Inside that, we have required provider section. This is critical because it tells Terraform which provider needs to be in our infrastructure. In our case, we are using Azure RM provider, that is Azure Resource Manager provider. We have specified HashiCorp/Azure RM, which tells Terraform where to download this provider information. HashiCorp is a company that maintains official Azure provider for Terraform. I'm going to initialize this. Let me run Terraform init. The initialization is in progress. Let's watch what is going on during initialization. First, Terraform initializes the plugins. Since we haven't provided any specific version, Terraform downloaded the version 4.47.0, which is the latest version. Notice it says signed by HashiCorp. That ensures that we are getting the authentic verified provider. And we see here there is another file called Terraform log.hcl got created. Here we see the version information. Now let's run the main.tf with a specific version. I have specified the version as 4.14.0. Now let me run the Terraform init command. We are telling Terraform to use a specific version 4.14.0. But here is the problem. Our log file which we created earlier has the version 4.47.0 and the main.tf file we have specified the version 4.14.0. So now we have a conflict between what we have requested in our configuration and what is in the log file. So that's the reason we got an error. To fix this issue, I have a note given by Terraform to run Terraform init-upgrade. This would update the log file to version 4.14.0 to match our new constraint. Let's run this command. This upgrade command tells Terraform to update the log file with the new provider version based on our constraint. Let me see the log file. Now our log file is updated with the version 4.14.0 and we have the constraint 4.14.0. We got the message that Terraform has successfully initialized. Now our configuration and the log file are in sync. Both are using the same version. Both the configuration file and the log file are in the same version. I hope you got a fair idea of Terraform versioning, and I'm sure that you learned something new today. If you do like this video, please consider to subscribe, and I will see you in yet another interesting video. Thank you.